So what are we going to do here? We want to write the simplified standard form equation of the parabola with focus at the point 6,2 and directrix at y equals -4. Okay, so let's think about this for a second. What are some things you'd want to know about or kind of focus on before you start doing this problem? What's one thing?
I like the P.
Say it again.
Like the P.
Yeah, okay, we're going to want to find P. We're going to need to find P and what else? Vertex, H and K. And that's really all we've got to do. But then there's one other part of that. Which standard form equation are we going to use? Now, don't say anything yet. Everybody look up here and see if you can, without drawing a picture here even. And if you want to sketch one, that's fine. But let's just, for a second at least, let's try to do it without me. Which standard form equation is it going to be? Because we've got different standard form equations for a vertical parabola, one where the parabola opens up or down, compared to one that's tipped on its side, opening left or right.
One where x is minus h.
Okay, this is going to be an x minus 1, isn't it? How come?
Because the directrix is...
Perfect. Okay, good. Very good. Okay, the directrix is a horizontal line, isn't it? Which means that the parabola has to open vertically, right? Okay, so we know then that we're going to want to use the standard form x minus, what's it going to be? What's the standard form?
Equals 4.
X minus, just in general,
H.
x minus h squared equals 4p y minus k. We've just got to plug in those values, right? Okay, so if the focus is at, if it's a vertical parabola, right, and the focus is at 6,2, then if we want to write the coordinates of the vertex, which one of those coordinates do we all automatically know? The 6, yeah, because if it's a vertical parabola, the focus and the vertex are going to line up vertically, right? They're both going to sit on that, the line that's the axis of the parabola, right? If I graph a parabola, there's the vertex, there's the focus, right? They're both going to sit on that axis of symmetry of the parabola, right? So we know right away that that's a 6, okay? How are we going to find the y value?
Find the average of 2 and 4.
Yeah, it's got to be halfway between the y value of the focus and the y value of the directrix, right? So we'll just average those two. What's the average of those two? -1. Okay. So there's h and there's k. How am I going to find p?
The distance between those.
Okay, but I'm starting where? I'm going moving from the what to the what? Vertex to the focus. Good. So we're going to move. So if we want to find out what P is going to be given to us by that value to that value. So how much is y changing from the vertex to the focus? +3. Everybody agree? We're done. Plug that stuff in and you're done. Right? Make sense? Okay. What about something like this? So this is a systems problem. Solve the systems. So what are we going to do here? What are our options?
Substitution.
We could use substitution. We could use elimination. I guess I could push the y to this side. Why not just use substitution? Okay, what's the variable? Now, which variable are we definitely going to want to substitute for? Y, yeah. And how come?
Because it's always axis.
It's on, yeah, it's well, it's easy to isolate, but also it's on the outside, right? Does that make sense? We'd rather not, like if I solve for x, I'm going to end up getting some, like if I were to do that, I would get some fraction of y plus some fraction of 9. When I put that inside here, whoops, when I put that inside this quantity that's being squared, that's going to get messy, isn't it, right? We'd rather not contaminate the x plus 9, because that's easy to square out, right? But if we added fractions in there or coefficients of x or y, then it's gonna start to get ugly, right? So we'd rather just focus on, and these are the kinds of things in math, when you start to get into like higher math, like you guys are approaching here, those are the kinds of things you want to start thinking about, is that's the substitution we want to make right there. Okay, we do a lot of this kind of thinking in calculus. Okay, so what's our, if we solve for y here, what's our substitution equation going to be? If I isolate y, I get what? 2x plus 9, good. What should we do with that equation? Remember me talking about this ever? When you isolate a variable for substitution, this is just my own thing, but I think this is a good thing. I always put a box around it because it makes it easy to identify that's the substitution equation. And typically when you're solving a system like this, you're going to want to know the solutions for both x and y, right? We want an ordered pair. So eventually we're going to have to come back and plug in a value of x to find the corresponding y value. And that's where we go. Just go to the box. Okay? So we make our substitution then. If we plug this in there, let's see what we get. So we get 2 times the quantity x plus 9 squared equals that, right? Equals 2x plus 9 right? Plus 9. Questions on that? Does that make sense? Okay, what have we done there? That's a big deal. I mean, it's, and you guys are already familiar with this, and you're good enough at algebra, you probably have a sense for this, but that's a big deal because now we've eliminated a variable, right? And so now we've put ourselves in a position where we can solve this. One way or another, we can solve this, right? Because we've only got a single variable in there. Okay, so what next? Simplify. So we're going to get 2 times x plus 9 squared equals, and I'm not going to square that out yet. And I'll talk about y in just a second. It wouldn't be wrong to do it, but I'll tell you what my thinking is on that. Why maybe didn't I square that out and distribute the 2?
Because you can divide by 2.
Good, because I can divide by 2, right? I can divide each side through by 2. Okay, which makes things easier, right? And then I end up with x plus 9 squared equals 2x over 2 is just x, 18 over 2 is 9, right? And now that's not looking too bad. That's the kind of problem that you guys would have been solving. You know, we've already done stuff like this, right? Back when we were solving quadratic equations using completing the square or the quadratic formula, you had some problems like this, and it wasn't that big a deal. Now what would I do? I have to square that out, don't I? I have to expand this. Unfortunately, I can't just isolate x because I've got 2 x's there, and I can't, as long as this x plus 9 is being squared inside that quantity, I can't combine them, right? So unfortunately, I do have to expand that out. So what am I going to get if I expand that out?
X squared.
Okay, plus 18x plus, and all we're doing there, right, is I just get x squared plus 2 times x times 9 plus 9 squared, right? Equals x plus 9. Any questions on how we got that so quickly? Does anybody not remember that? Question on that? Here's the pattern we use. I just want to make sure everybody remembers this. The pattern is just, if I ever have a binomial, say like a plus b squared, that always is going to expand to a squared plus 2ab plus b squared. Okay? Just a little shortcut. Do you have to remember that? No, it's helpful. If you didn't, of course we could always just manually multiply that out, but things like this make algebra a lot quicker and easier. And there's a few of them like this that are really good to just kind of have at hand. All right, moving on. Now what? Okay, we got to put it in standard form, right? We're going to set it equal to 0, so we're going to push everything to the left. So if I subtract x from both sides, I get 17x, subtract 9, get 72. And now what do we have? What would we call that? A quadratic equation in standard form. So let's back up a little bit here and think about what our options are, right? We have lots of strategies for this, but we want to treat this kind of like a triage in a hospital, right? We want to make sure that we can try the easiest stuff first, and then we'll only do the more complicated things if necessary. So what's probably the first thing we'd want to try here? Yeah. This would be an easy one to factor because a is equal to 1, right? There's no coefficient of x squared. So all we've got to do is just ask ourselves, are there some simple magic numbers that work? What are they? 9 and 8. Right, so this factors into x plus 9 times x plus 8 equals 0. So what are my solutions? Okay, good. We get x. Either we're going to get, oops, that's supposed to be an x. X equals negative 9, right? Or x equals negative 8. Well, let's just try each one of those. What if we take the case x equals negative 9? How am I going to find x? Plug it in right there, right? That's why we put a box around it. So what do we get here? 2 times negative 9 is negative 18. Plus 9 is what? It's negative 18 plus 9. Negative 9, right? So we get when x equals negative 9, y equals negative 9, so we get the ordered pair negative 9, negative 9. Okay, let's try the other one. What if we have x equals negative 8? Well, that's going to give us 2 times negative 8 is negative 16. Negative 16 plus 9 is what? Negative 7. So negative 8, negative 7. Whoops. That's our other solution. Okay, make sense? Okay, let's do one more of those. How about something like that? What do you think? Same kind of thing, right? Substitute. Which variable are we going to substitute? Y. Good. Okay, so if we solve for y, we get y equals what? Negative x plus 9. There it is. Okay, so then we end up with x minus 1 squared equals y, which is going to be negative x plus 9 minus 3. Okay? And so that gives us x minus 1 squared equals negative x, what, plus 6? Okay, what next? Okay, I've got to expand the binomial, right? And if I do that, I get, oops. I get x squared minus 2x plus 1, right, on the left side. Everybody agree? Equals negative x plus 6. We'll just push everything to the left and put it in standard form. So we end up with x squared. If I add x to both sides, I'm going to get a negative x on this side. Subtract 6 and get minus 5. So there's my quadratic equation in standard form. So we're right back to that place again. What do we want to try first? Yeah, are there magic numbers? There are not this time. So what are our options? Quadratic formula or complete square. Let's just go quadratic formula, right? So real quick, what is our, if we start off with the quadratic equation in standard form, what does the quadratic formula tell us? X equals, it's not very musical, plus or minus
Square root.
C squared minus 4ac, all over 2x.
Okay, so what's A? What's B? Negative 1, good. What's C? Negative 5. Plug and chug, right? So we end up getting x equals, what's negative B then? 1. Okay, opposite of negative 1 is 1, plus or minus square root 1, right? Negative 1 squared is 1, minus 4 times 1 times negative 5, makes that a plus, right? All divided by 2. So that's just equal to 1 plus or minus the square root of 1 plus 20 is 21 over 2. Can we simplify square root of 21? No, we can't. So those are our two answers for x, right? So let's try each of those. If x equals 1 plus the square root of 21 over 2. What's that going to make y? Well, we got to go back to our substitution equation. Y equals negative x plus 9. Let's write it like this, how about? Y equals 9 minus x. How about? Okay. So y equals 9 minus that. How am I going to do that? What do I have to do when I want to add fractions like that?
1/2.
What are you going to say?
1/2 plus square root of 21.
Okay, I could do that. I could split everything up. I heard something else. What do I need in order to combine these separate fractions? Common denominator. So I could just multiply top and bottom by 2, right? And what's that going to give me? Now I've got my common denominator of 2 on the bottom, right? So this is equal to 18. There's my 2 on the bottom. I get 18 minus 1 plus square root 21, right? But I'm actually subtracting the whole thing, aren't I? Right, everybody agree? Should have put parentheses there. So what do I have to probably do here? I gotta come over and, right? Everybody agree? So this is technically gotta be, if I distribute that negative sign, that's gotta be a minus. Does that make sense? Right? Okay? So then what do I end up with? What's that simplified to? 18 minus 1 is 17. So we get 17 halves minus square root of 21 over 2. Or I could just say 17 minus square root of 21 over 2. Let's just do that. We can keep our common denominator, that's fine. 17 minus square root of 21 over 2, right? So my ordered pair looks kind of ugly, but it's the answer. It's an exact answer, too. So one answer is the x-coordinate is 1 plus square root of 21 over 2, and y is 17 minus square root of 21 over 2. And then we could do the very same thing. Maybe we won't even do it. We could do the very same thing for our other solution, which is x equals 1 minus square root of 21 over 2, right? We could substitute that in to this equation and solve for y. Now get the other corresponding value of y. Does that make sense? Okay? Yeah, go up or go that way. Okay. So we would just make sense? Do we need to go through, are we okay on the parabola stuff then? Do we need to go through one where we choose a graph, or do you think you're okay on that stuff? Maybe just ask me individually if you have any issues like that. Okay? Grab a Chromebook. Yep, go on.
I tried one of those ones I'll say that you set up to do,
Uh-huh.
and because I had math last night.
Oh, you can do them. They're just really hard.
Yeah, it's very hard.
Yeah.
We have like the denominators right and everything. We made a little, I don't know where we made a mistake, but then he redid it after I left, and he said to substitute for the other variables. We did the wrong variables.
Yeah, you'd want to take a little time and focus on the right
And then he
variable.
said he got it right after that, so we got really close on our first try.
Yeah. So you saw that you weren't supposed to do it anyway, right? First though?
Yeah.
Okay, good.
We skipped them, and then we had time, so we went back and then
Oh, I
tried
got you.
it.
Okay. I actually, this is one of them. I changed the parameters so the numbers aren't as big. That was the big thing. The numbers just got
Yeah,
so big.
I was gonna say, 'cause I was like, none of the other ones answers like that, so.
Right.
I remember at the beginning of the year last year when we were doing the algebra review, I remember one of the questions I had an insane fraction that was like
Yeah.
over 100,000 over 35.
I remember that.
It was like this insane fraction, but it all lined up to it, so the answer was it was still a nasty fraction.
I'm actually gonna reassign this one on the next assignment. So you don't have to do it.
It's assignment basically just harder questions.
Well, I'm gonna put this one.
It's okay.
Katie, I'm gonna put this one on the next assignment, just so you guys have to do one with radicals, but I'm also gonna put a challenge question, which is, it's not as bad as that one you guys are doing, but it's still it's pretty good. It'll be, I don't know if I'll even make it worth any points, but just kind of have it be like a bonus question or something, but you should do it.